Okay, so these are the solutions to the post-Easter paper 1 progress check, non-calculator. Question 1. Sum of money is shared in the ratio of 3 to 4 to 7. The smallest share is £210. So what is the total amount of money shared? So with ratio questions, very often they give you the total amount and ask you to divide it into the ratio 3 to 4 to 7. In this particular one, what it's saying is that this part here is equivalent to £210. So to work out what the other ones are, first of all you need to use this information to work out what one part is worth. So if 3 parts is worth 210, one part will be 210 divided by 3, which is 70. So each part is worth £70. So this will be 4 times 70, which is 280, and this will be 7 times 70, which is 490. The question isn't asking you what the other parts are, it wants to know what the total amount is, so we then have to add the 3 values together. So 0, 18, and then we got 5, 9. So the total amount of money shared is £980. Question 2. Right, the table below shows some values of y equals x squared minus 4x minus 3. The values of x from negative 2 to 5. So this is drawing graphs of quadratics. The graph is not a very nice one, or sorry, the graph will be fine. The graph paper isn't very nice. It's quite difficult to figure where everything fits. But we'll do what we can. In the real exam, the quality of this will be much clearer as to where the 10 marks are. Right, so when we were doing this in class, what I suggested you did first of all was to plot the coordinate pairs that they give you, because that will then give you a sense of when you're calculating the 2 missing ones, whether or not you've got it right. So the first one we're going to plot is minus 1x against y of 2. So minus 1x against y of 2. Then we've got 0 minus 3. We've got 1 minus 6. Now I'm not being ultra careful here because I just want to get through this relatively quickly for you. But as I said, in the real thing it will be clear that you're at the right place. 2 we don't know yet. 3 is minus 6. So that will be there. 4 is minus 3. And 5 is 2. So it's an x squared expression, which means we're expecting the curve when we make it to look something like that. So the first one that we need to calculate is when x is negative 2. So when x is negative 2, in order to make that smiley shape, I'm expecting a y value up there. So if I end up with an answer which is 2 or minus 1, then it's not going to fit in the pattern. So I'm anticipating something around about 6-ish. Anything else I need to check. And then similarly, for plus 2, I'm expecting something to keep that U shape going, probably about minus 7-ish. So with those in mind, I can then calculate and make sure that I'm in the right place. So when x is minus 2, y will be, so in this expression now, wherever there's an x, we're going to replace it with minus negative 2. And where there's an x, we replace it with a bracket. So that's going to be minus 2 squared minus 4 bracket minus 2, take away 3. Minus 2 squared means you're multiplying it by itself. So minus 2 times minus 2. 2 times 2 is 4. Minus times a minus, sign's the same, answer's positive. So that becomes 4. With this one, I got 4 times 2 is 8. And again, minus times a minus is a plus, take away 3. So those minus minus rules only apply when you're doing a multiplication, so getting rid of the brackets. Once we've done that, we're moving up and down the number line. So it's arithmetic. 4 add 8 is 12. 12 take away 3 is 9. So that point is 9. So if we just go now, minus 2, that's about right. That's kind of fitting my slope, so I'm happy with that. And then the second one is when x is plus 2. So y will be 2 squared minus 4 bracket 2 take away 3. 2 squared is 4. 4 times 2 is 8, but this time signs are different, negative, positive. Answer is negative, take away 3. So we're doing 4 take away 8, which takes us down the number line to minus 4. And then taking off another 3, minus 4, take away 3, minus 7. So when x is 2, y equals minus 7, which is what we were looking for. Okay, so that's plotted. I didn't mention the how the marks were going to be awarded here. So you'll get a B mark. I'm looking for the number 9 for that coordinate. If I see it, you get the mark. If I don't, you don't get the mark. So that's a B mark. And then you get another B mark for negative 7. We then get a P mark for correctly plotting the points. And then finally a C mark, which I haven't earned yet, for drawing the curve. When you're drawing a curve, if you remember when we were practicing this, I always suggest you turn the paper around so that your wrist, your hand, is in the inside of the curve. It makes drawing the curve much easier because your wrist acts as a pivot. You mustn't use a ruler. You must use a pencil in case you muck it up. Okay, I know I'm not. Okay, and you make sure that you've got that free curve looking like something like that. So that's your C1 for plotting the points and then joining them with a curve. Part B, on the graph paper opposite, right, we've earned those 2 marks. Draw the line y equals 1 on the graph paper. Okay, so when we were doing this, and also when we were practicing transformations, and we were doing reflection, and the mirror line was either y equals something or x equals something. It's really important that you're clear whether you're drawing a horizontal line through one or a vertical line through one. Okay, the wrong one is the vertical line. The vertical line takes you through x equals 1. The x coordinate is 1. And if you're not sure, you can see there that that line, if you drew it, only crosses the curve in one place. And yet the question is giving you 2 gaps to fill in. So it's expecting to cut twice. That's because y equals 1 goes through the y coordinate 1, which is actually a horizontal graph. So that's the curve y equals 1. So they want to draw the line y equals 1 on the graph paper, write on the values of x where the line y equals 1 cuts the curve. So they want you to work out what that value there is, okay, which is minus 0.9, and this value here, which is 4.8. So minus 0.9 and 4.8. Now if your curve is slightly different, you may get nothing there, but if you correctly draw the line y equals 1 and then write down the coordinates, the values, x values on your curve, you would still get those marks. I realise I haven't gone back to give you the marks for this one. So there's a method mark for this one, and the method mark is for finding the value of one part. Then you're going to have an answer mark for the two missing parts, so the 280 and the 490, and then a final answer mark for adding your values up to get the total. Okay. Question 3. Rearranging the formula. So you're rearranging the formula to make K the subject. So you want, rather than having P equals, you want to make K equals. In order to do that, you follow the rules that you would in order to solve an equation. First of all, in order to get that K on its own, we need to get rid of the plus 2. To get rid of the plus 2, we have to take 2. If we take 2 from that side, we have to do the same from that side in order to maintain the balance. So on this side we end up with P minus 2, and on this side we end up with 3K because the 2 has gone. Now to get the K on its own, we need to divide by 3 because the 3 and the K are connected by a multiply. So I have to divide that by 3. That means I have to divide that by 3 too. So that gives me K on its own on that side, because 3 divided by 3 is 1. And on this side, P minus 2. And in algebra, we write the divide like that. So that means we've got the K on its own, which means we can just write it the other way then. So K equals P minus 2 over 3. I know when we did this in class, there was some discussion about when you do this divided by 3, you would write P minus 2 divided by 3 equals K. You have to be really careful if you don't use the algebra form, because if that's what you've written, it's wrong. The only thing there that's being divided by 3 is the 2. If you'd have put that in brackets, then that's actually correct. So the main thing is this: divide, when written like that, is arithmetic. In algebra, when we divide, we actually write it as a fraction with the divisor, the thing we're dividing by, underneath. That's just something to be careful of. Express 0.0058 in standard form. Okay, so we've done quite a bit of practice on standard form. If I just write it here, 0058. Standard form, you've got the numerical part, which needs to be between 1 and 10, times 10 to a power. Now when we were practicing this in class, I was getting you to write down what the place value columns were in each case. So the unit column is 10 to the 0, when with this side of the decimal point we have negative powers. 10 to the minus 1, 10 to the minus 2, 10 to the minus 3, 10 to the minus 4. We read off the times 10 column that the most significant digit is in. So it'll be 5.8 times 10 to the minus 3. We also practiced multiplying and dividing standard form numbers and adding and subtracting. This is a multiplying divide, and what you do here is you deal with the number part and the power part separately. So we're going to do 1.4 divided by 2, which is 0.7, times 10 to the power of, and then this is the laws of indices. When the bases are the same, so they're both to the power of base 10, if you're dividing, which we are, you subtract the powers. If we were multiplying, we'd add the powers. So that's going to be 0.7 times 10 to the 9 take away 3, which is 0.7 times 10 to the 6. Now we need to give our answer in standard form, and that isn't in standard form because that isn't a number between 1 and 10. So we need to turn that into standard form, which would be 7 times 10 to the power of, now if we quickly look up here again, 0.7 would be times 10 to the minus 1. So 0.7 is 7 times 10 to the minus 1 times 10 to the 6. Bases are the same. We're multiplying, so we can add the powers. So we end up with minus 1 plus 6, which is 5. Haven't mentioned the mark scheme here. So for rearranging the formula, you'll get 1 mark for getting it to p minus 2 is 3k, so you've dealt with 1 bit of it, and then the second mark for dealing with the 3. This is just right or wrong. This, you get 1 mark if you got it to 0.7 times 10 to the 6, and the second mark if you then correctly turn that into standard form. Okay, part 5, factorize and solve. So this is a quadratic, which we learned how to do before Easter. So if you remember, I get you to multiply the number in front of the x squared by the last term, the number on its own. So in this case, that's plus 12. I then list the factor pairs of 12. 1, 12, 2, 6, 3, 4. The next one will be 4 and 3, so they're repeated. And I'm looking for a way of combining a pair to make minus 7. So I can't do that with 1 and 12 or 2 and 6, but if that was negative and that was negative, they would add to make minus 7. I then rewrite the quadratic, but instead of having minus 7, I write minus 3x minus 4x and then the plus 12. You then deal with each pair separately and look for common factors. So the only thing that's common there is x. If I take x out, it leaves me x minus 3, and you can check that by multiplying it back. X times x is x squared, x times minus 3 is minus 3x. You then look at the second pair, and out of that second pair you need to still end up with x minus 3 in brackets. So what can you take out? You can take 4 out. If that was a plus 4, you'd end up with plus 4x, and you need minus 4x. If you make it a minus 4 times x is minus 4x, 4 times 3 is 12, minus times a minus is a plus. So you've got that right. You've then got x minus 3 as a common factor in each of those parts. And if you take that out, it leaves you x from the first and minus 4 from the second. So the factorizing x squared minus 7x plus 12 is that. You then put that equal to 0. And then to solve it, you're looking to see what value. So either that has to equal 0, which would be x equals 3. To get the x on its own, you add 3 to each side. So x equals 3 makes that go to 0. Or you say x minus 4 equals 0, which would be x equals 4. For the second part, expand and simplify. So if you're squaring something, you're multiplying it by itself. So you would write it like that. It's a double bracket. You use FOIL when we practiced in order to expand that. So you do first that one times the first in that bracket, 25x squared. Outside would be 5x times negative 2 minus 10x. Inside also minus 10x, and then last would be 2 times 2 is 4, minus times a minus is a plus. You can tidy that up a bit because we've got two values in the middle. 25x squared minus 10, take away another 10, takes you to minus 20x plus 4. Okay, so marks for this one. You would get a method mark for a correct, complete method of factorizing, an answer mark for factorizing into the double brackets, and then one more for the two values of x that solve the equation. With this one, There'd be a B mark if I saw that complete expansion, and a second mark for simplifying the middle part. Okay, describe fully the single transformation that takes triangle A onto triangle B. It's worth 2 marks. That means you need to say 2 things about it. The first thing is that it's a reflection that has been reflected onto B. So first mark, it's a reflection, and with a reflection you need to say where the mirror line has been placed. Now the mirror line is there. That's what would fold over to make that, and you would describe that as x equals -2. So reflection, 1 mark, in line x equals -2, because it's the x going through -2 coordinate that gives you that. 2 marks. Translate triangle A using the column vector 5 - 6. The top digit gives you the x motion. The bottom one gives you y motion. So let's take that point there. That point there is going to end up 5 units plus 5 units in the x, 1, 2, 3, 4, 5, and -6 in the y, 1, 2, 3, 4, 5, 6. The only one that changes the size is an enlargement. So once you know that that is there, everything else is going to follow. So that corner there will be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, and that one would be 2 above. So the 2 marks for that, so 2 marks there, 1 for saying reflection, 1 for saying where the mirror was. And with this one, there's 1 mark if you've moved that correctly horizontally 5 spaces, and the second mark if you've also moved it vertically downwards 6 spaces. And then at the bottom, this is asked quite often, write down the column vector that will reverse the translation in part 2. So what would happen, what would the vector be to turn that shape back to there? And what would happen is you'd need to change the symbol, the signs there. So you'd be going left 5, up 6. So -5 plus 6, or just -5, 6 would get you that 1 mark. Question 7, probability trees. This was covered when I had COVID. Hoping that you've been able to manage this. So a group of people have put their names forward to carry the Welsh flag at a sporting event. Each person lives in North Wales, Mid Wales or South Wales. One person from the group is chosen at random. The probability that of choosing a person who lives in North Wales is 0.3. So that's here on your diagram. The probability of choosing a person who lives in Mid Wales is 0.25. And then the probability of choosing a person who is under 18 is 0.2. People's ages are independent of where they live. So it doesn't matter how old they are, makes no difference on where they live or vice versa. Complete the tree diagram shown below. So the branches have to add up to 1 because total probability is out of 1. So these two add up to 0.55. So to make them all add up to 1, the missing one is 0.45. And then when we come to under or over, person under is 0.2, which means this has to be 0.8 because they're either under or they're over. And then that is repeated on each of the branches below. So for that, there's 1 mark if I see 0.45. There's 1 mark if I've got a correct branch of 0.2 and 0.8, and then the final mark is for the complete diagram. What is the probability of choosing a person who lives in South Wales and is under 18 years old? So on our diagram, South Wales is along that path and is under 18 is that path. Now when you're moving in one direction on a probability tree, you multiply their probabilities. So South Wales and under 18 will be 0.45 times 0.2. Now this is a non-calculator paper, so you need to be a little bit careful here. 45 times 2 is 90, but if it was 2 times 0.45, you'd have 0.9. Now 0.9 is the most common wrong answer here. When you're multiplying decimal numbers like this, the total number of digits after the decimal point in the question is the number of decimal points in the digit after. So what we have here is 45 times 2 and to have that two decimals it would have to be 0.09. So 0.45 times 0.2 is 0.09 and not 0.9. So you'd have 1 mark there for the method of doing 0.45 times 0.2 and 1 mark for correctly getting 0.09. Question 8. Circle the expression which is equivalent to m to the power of 2/3. So these are indices. We did quite a lot of practice on these earlier in the spring. When you've got a fractional power, the number on top of the power, on top of the index, on the indice e, is the power. So that's basically squared. And if there's a fraction, that's a root. So this is saying we've got the cubed root of m squared. Cubed root of m all squared. Okay, so that's what we're looking for, which is that one. If that was, say, m to the a half, then that would be square root of m to the power of 1. Okay, so the number on the top, so if we had m to the 4/3, cubed root of power of 4. Okay, so that's how that works. The only other bit of information they can put up there is a negative, and if it's a negative, it means it's reciprocal, and you would turn it round the other way. Circle the expression which is equivalent to p to the 3/4 times p to the -1/4, and that hasn't come out very clearly, but is a divide. So they're all to the base p, and when you multiply you add the powers, so that's going to be 3/4 plus -1/4. And then divide means you're going to subtract the powers. So I got 3/4 plus that one, which happens to be a -1, and then take away that one, which happens to be a +1. That, signs are different, actually means a minus. So what we've got is 3/4, take away 1/4, which is 2/4, take away another quarter, which leaves 1/4. So 3/4 take away 1/4 is 2/4, take away another quarter, leaves a quarter. So it's that one. So B1, they're right or wrong. But just because it's a multiple choice, that doesn't mean that you shouldn't do any work. Okay? Do your workings and then match to that. Question 9. Express the following as a single fraction. So this is the thing that we were calling Mrs. Williams's kiss and smile. So we multiply to get the top. It's going to be 6 multiplied by that. So 6 bracket 2x plus 1 minus 4 bracket 3x minus 5, and then the smile for the denominator is that times that, and we leave that in brackets. So we've done all we're going to do to the bottom, but we can tidy up the top. Get rid of the brackets. So I've got 6 times 2x, 12x plus 6. 4 3s are 12x, minus times a plus is a minus. 4 times 5 is 20, minus times a minus, the signs are the same, that becomes positive. All over 3x minus 5, 2x plus 1. Bit more tidying I can do up here. 12x take away 12x is 0, or nothing x, but we write it as 0, or we don't write it at all. 6 plus 20, 26, 3x minus 5, 2x plus 1. And there's no further simplification that we can do to that. So that's the final answer. 3 marks. Method mark for the kiss and smile. Accuracy mark, answer mark for clearing out the brackets correctly, dealing with the minus, and then your final mark is for the final simplified answer. Question 10, recurring decimals. So we write this with as a decimal string with our repeated parts in. So you let x, doesn't have to be x, but that's what we use, to be 0.8, and then 8 isn't part of the repeat because it doesn't have a dot over it. So 1, 2, 1, 2, 1, 2, and so on. So what we have to do is work with multiples of this in order to eliminate the repeating part, 0.12, 1, 2, 1, 2, 1, 2. And we do that by multiplying by 10, 100, 1,000, which has the impact, if we multiply by 10, of moving that along one place, so it would be 8.121212. So we can do that, and I get 10x, because I multiplied by 10, equals 8.121212, and so on. Now, if by subtracting that one from that one, the decimals all lined up so that they cancel each other out, then we could do that. But because I've got that 8 there, that's not going to work for me. So I've got to multiply by another power of 10. If I multiplied by 100, I'd have 81.21212. That still wouldn't subtract because it starts with a 2, not a 1. So this one I need to multiply by 1,000. So when I multiply by 1,000, this moves 3 columns to the left, and I get 812.12121212. That means now the decimal side of that all matches up. When you subtract it, they'll all become 0. So I'm going to do 1,000x take away 10x, which is 990x. And this side, it'll be 812 take away 8, which will be 804. So to get the x then, to create our fraction, I divide by 990, and my recurring decimal as a fraction will be 990 divided by 804. So there's a method mark for that one, for correctly ending up with 2 terms which will align the decimal repeat, and 1 mark for the final answer. Now we move on to surds. When we're working with surds, the bit of maths you need to remember is that if you've got two values multiplied together under a root, then that can be broken up into two separate roots, and that works both ways. Sometimes it's helpful to combine them, as we'll see further down. Sometimes it's helpful to split them up. So what you need to do is because none of these has got a square root of 72, so you need to look at what factor pairs you can split 72 into, one of which is a square number, which means you can take its square root as a whole number. So 72 is 9 times 8. Okay, so the square root of 72 is the square root of 9 times 8. Square root of 9 times 8 is the same as the square root of 9 times the square root of 8. Square root of 9 is 3, so that is 3 root 8. Now 3 root 8 isn't there. And that's because I didn't pick a larger factor pair which also has a square root, which is 36 times 2. So if at this point I would have gone 36 times 2 instead, then that would be the square root of 36 times the square root of 2. The square root of 36 is 6, because 6 is a 36. So that is 6 root 2, which is there. Using my first attempt, I can write the square root of 8 as the square root of 4 times the square root of 2. Square root of 4 is 2, so that would be 3 times 2 times the square root of 2, which is 6 root 2. So if you'd have ended up going my route, you'd still get there, but you'd need a second bite at it, because I didn't pick, when going through my 72 times table, the largest factor with a square number. So just one mark for that. Expand and simplify. So this is FOIL again, but this time we've got surds sitting in there. So first, 7 times 3, 21. Outside, 7 times root 5, 7 root 5. Plus times a plus, positive. Inside, 2 times 3 is 6 root 5. Minus times a plus is a minus. And then this one is going to be plus times a minus, minus 2 root 5 root 5. Now when you're multiplying a square root by itself, it just undoes it. It just becomes the value underneath. Because root 5 times root 5, using this in reverse, is the same as the square root of 5 times 5, which is the square root of 25, and the square root of 25 is 5, because 5 squared is 25. So when you are multiplying a root by itself, it just undoes the root part of it. So I've got 21, 7 root 5 minus 6 root 5 is plus 1 root 5, 7 take away 6, and this is going to be 2 times 5. So I've got 21 plus 1 root 5, which you can just write as root 5, take away 10. 21 take away 10 is 11. So you got 11 plus the square root of 5. There's 2 marks for that. 1 mark is for correctly multiplying out your bracket. So even if you get in a fug when it comes to dealing with the surd part of it, as long as you can use FOIL, you should get that mark. And then the second mark is for doing the simplifying, making sure that you've simplified the root 5 parts, you've dealt with the root 5 times root 5. And then the final question on paper 1 is at the back of the paper. So this is a grade A transformation which means it's the negative enlargement. Okay, so you're going to be looking for this in the second half of the paper. So there's 3 marks. Describe fully the single transformation that transforms shape A onto shape B. So it's half the size. So although it's called an enlargement, it's shrinking it, but it's still an enlargement. So that's your first mark. You've spotted it's an enlargement. Then you say the scale factor. It's been halved. That's 4 squares. The corresponding side is 2. But it's also been flipped, and that means it's a negative scale factor. That's the bit that makes it grade A. This question wouldn't be on the intermediate tier paper. The transformation ones we did earlier would have been. So if this is in the second half of the paper, it's almost certainly going to be a negative scale factor. That's the second mark. To get the third mark, you need to say where the center of enlargement is going to be. And in order to do that, all you need to do is join the corresponding sides of your shape. So you know that that one is going to end up there. This one is going to flip around to there. And this one is going to flip around to there. And where those lines intersect is the center of enlargement. So this one will have a center of coordinate pair 1, 0. So 3 marks, 1 for saying it's an enlargement, 1 for the correct scale factor minus a half, and 1 for the center of enlargement. Okay, so hopefully you found that useful. Hopefully there were lots of questions there that you scored marks on. What you need to do is learn and practice the bits you didn't. So if you couldn't do the surds question, go back into your notes, read through the surd stuff again, practice the questions that we worked on when we were doing that, and then come back and have another go, and so on.